In today's lesson, we started chapter 3, where we moved from multiplying a 1-digit number by a 4-digit number to multiplying 2 digits by 2 digits. We reviewed that in chapter 2. We were learning strategies for multiplying 6 times 7, or 6 times 17, 6 times 317, all the way up to a 4-digit number like 3,174. Students learned 3 different strategies and several mental math strategies for solving these problems. We haven't yet reached the standard algorithm or regrouping, which is the way that we've been taught just yet. We're still developing a conceptual understanding of multiplication of many digit numbers. So we'll continue in chapter 3 using the same strategies we used in chapter 2, but using them in a little bit of a different way to multiply 2 two-digit numbers. So to start for today, we looked at 2 numbers. One at least had a 0 within it. So we had 30-second cartoon and looking at 20 frames per second. So in this case, we're looking at 20 times 30. We started by thinking of one of the factors as 10, 20 groups of 3 tens, and 20 times 3, we would have 60 tens. And utilizing our place value system, when we have a 10 or tens, we're thinking we're adding 1 0. So we have 600. Students typically understand this when they're given the base 10 blocks to understand it with manipulatives, but they don't usually write their problems in this way. Another way of solving this, using something that we've talked about with the associative property, and they've learned in past grades as well, thinking of this second factor as 3 times 10. That way we're breaking up 30 into 2 smaller factors that they can work with. We learned that 20 times 30 is 60, and multiplying that by 10 is 6 times 1, which is 6, and we have 2 zeros, which is similar to this last strategy. Finding half of 20 will enable us to solve this problem 20 times 30, but thinking of 20 as half, 10 times 30, students can see that 10 times 3 is 30, 10 times 30 is 300, just like thinking 10 times 10 is 100. Then taking that and doubling it, because it's not just 10 times 30, it's 20 times 30. So by doubling that, we find that 20 times 30 is 600. Students then, after looking at some strategies we've seen in chapter 2, went in solving 20 times 27. Now, 20 times 27, we can think of 27 as 20 plus 7. And we can use our area model that we used in chapter 2. By breaking up that one factor, we can look at patterns with a basic fact. 2 times 2 is 4. And then we have 1 0 and 1 0. So a total of 2 zeros. And then 20 times 7. 2 times 7 is 14. And we have 1 0 in that product. So then they can add the 2 partial products to get 540 as their final product. Also, students could think of it in other ways, 27 plus 27, and that's 2 groups of 27. And then adding a 0, because it's not just 2 groups, it's 20 groups. Within the student's math spiral, we looked at one type of word problem in which an arena has 40 rows, and each row has 30 seats, looking for the total number of seats in that section. The first one utilizes that place value strategy that we saw before. The second one using the associative property, where students are breaking up factors and then they're switching how they're multiplying it, or multiplying the first two factors first instead of the last two factors. This last strategy is the one that most students are utilizing, where they're looking at 4 times 3, the basic fact, and noticing how many zeros are within both factors. So in this last one, 4 times 3 is 12, and then there's 1 0 in each of those factors for a total of 2. And that's a strategy that they use when looking at the problems in the lower part of their spiral, where they were practicing their strategy. So for this one, 2 times 9 equals 18, and we see 1, 2 zeros, we have 18 and 2 zeros. So 20 groups of 90 is going to be 1,800. Again, they use that similar strategy for all of these example problems, picking out a basic fact and then adding how many zeros were in those two factors. Tomorrow, students will use this strategy to help them with estimating products, in which we round our factors in a way that gives us zeros with those two factors, so we can do mental math strategies just like this one we've learned today.